Welcome to the review for Unit 15. So we did a bunch of advanced functions. We did exponential functions, we did absolute value functions, and let's begin the review. We started with piecewise functions. So plot this. It's a pair of linear functions. You're plotting 1/2 x minus 6. You're going to want a straight edge. So the y-intercept is 0, -6. The slope is positive 1/2. And this is the part we only want it, so we don't want it exactly where I drew it. We want it for x is less than 0. So we want this part over here. So we want, right, so this is the linear, I'm going to do it the slow way. So that's the linear function. But we don't want the whole thing. We only want the part that is where x is less than 0. And so I need an open circle there. And then if x is greater than or equal to 0, we need the other part of it. So the y-intercept is 0, 1. The slope is positive 2. And so this is the other part of the function. And so that is called a piecewise function. And that's a piecewise linear function in this case. Clean this up. Now, you will not have to graph, obviously, although you might have a multiple choice of graphs to pick from, but you will have to be able to write a piecewise function. There it is, done again. All right. So what type of function is that? You should know from its shape, it's an exponential function, and it's an increasing exponential function. Decreasing ones face the other way. All right, so you're going to have to write a piecewise function for this graph. So it's f of x, and use these braces, and the dividing between the two pieces is at x is 3. All right, so we have one part for x is greater than or equal to 3. We have another part where x is less than 3, and they are linear functions. So write the two linear functions. This is the easier one. Why is it easier? Because you can see the y-intercept. You don't have to figure it out. The y-intercept there is 0, 5. What's the slope? Now this is, right, remember, you're doing this whole linear function. So the slope here, is down 1 over 3. We're only drawing this part of it, though. So the linear function for x is less than 3 is -1/3, right? We don't write the y because there's f of x over here. F of x equals -1/3 x minus 5. That's 0, -5. Okay. Now the other one is harder. Why is it harder? Because, right, you need the y-intercept. So let's get the slope first. The slope of this is 3. So we're going down 3, right? If I'm going backwards, we're going up 3 and over 1 for the slope. But we're going down 3 and over 1. Right, and so that's where the y-intercept is. Now you could do it the way I just did it, or you could actually just sit there with a straight edge and draw it to show you that. But that's the linear function for that part. But the problem is we only need the part where x is greater than or equal to 3. And so we just figured out that the y-intercept was 0, -8. Slope, we already said, was positive 3. So it's 3x minus 8 if x is greater than or equal to 3. All right, the domain and range. You'll definitely be asked about this. The domain is all the possible values of x. Well, it goes on forever in both directions, right? And there's no gap, right? 3 is covered. So this is all real numbers. And the range here, let's look at the range. They both point up, right? So there's no way we're going to get any y's below -6, right? You can't get, right, because both of them point up from there. And so the range is y is greater than, it's not or equal to, because I got an open circle there, greater than -6. The range is all the possible y values, -6 and lower, not possible for y. All right, so we're going to plot this. Now, right, this is f, you have three functions there, but these are all horizontal line segments. And that's why they look that way. This is a step function, it's called. And a step function is a piecewise function. It's just a special one. All right, so -8. Why is -8 when we're between 2 and 5? So here's 2 and 5. And we're at -8. So we're between 2 and 5. And I need closed circle on 2, open circle on 5. All right, that's our first step. We're at -6 if we're between 5 and 7. So again, we're between, this one is shorter. The first one was, and we need closed circle on 5, open circle on 7. And then we're at -4 with a closed circle for any number greater than or equal to 7. So that is our step function here. Domain and range. So what are the possible values of x? All right, it's not all real numbers. So make sure you understand why. All right, x can't be anything over here. But we have an arrow here taking care of all the numbers that way. So the domain here is x is greater than or equal to 2. The lowest number x can be is 2. Range, well, the range is always right there. By the way, you can see x here as well. So the range is -y, I should write y equals -4, -6, and -8. And that's it. Those three numbers can't be any others. All right, so work backwards and write a piecewise function for this graph. All right, so it's f of x is that, and we have a gap this time, right? So we have a section of if x is greater than or equal to 2, that's an if. We have another section for f if x is less than -6, right? And when x is greater than or equal to 2, y is 6, right? It's the y coordinate at every point on that graph is 6. And when f of x is less than -6, y is 5. That's the piecewise function. Domain and range. The possible values of x. So x, there they are. X can be less than -6, or x can be greater than or equal to 2. This is like an OR inequality, because we have this gap. That's why we need the or there. And the range is these two values. Y equal 5 or 6, doesn't really matter the order. All right, so we're going to plot this function. All right, so 1/3 times the absolute value of x. Well, you should know what shape an absolute value function is. What shape? Tell me what letter it looks like. Hopefully you're thinking V. Now, the plain old one goes, looks like that. That's f of x equals absolute value of x. But then we have shrunk this by 1/3. We've done a vertical shrink. So let's see how that plots out. Y equals 1/3 times the absolute value of x. So x is -9. Negative time absolute value of 9. 1/3 times 9 is 3. 6 is 2. 1/3 of 3 is 1. And these are symmetrical. Okay, so we're at -9, 3, -6, I'm doing these points, -6, 2, -3, 1, 0, 0, and then symmetrical points, 3, 1, 6, 2, and 9, 3. And so this is wider than the original function b because it's been shrunk. On one side the slope is 1/3, and the other side the slope is -1/3. But that is this absolute value function. All right, so I already said this. When you multiply by a fraction, you vertically shrink. Now, on the test, if I ask you this, I'll have two blanks. I wouldn't have this. So you'd say vertical in the first blank and shrink in the second blank. If I did this, 4 times absolute value of x, you would say it is a vertical what? Stretch, right? And then we would have a slope of 4, and we would stretch this thing, right? Like that. Make it look skinnier. All right, so we're going to have to work. Well, did I just give you the way? Let's see. You need the slope. No, I didn't do this one. Right, so you see a v. So you know it's f of x. You know it's absolute value of x. You know it's not upside down, so there's a number here, and it's going to be a positive number. And we hopefully know that with no number, or the number 1, you get that one. So this has been stretched. So we've multiplied it by some number, and that number is really the slope here. And so it is 3 times the absolute value of x. Is this a vertical stretch or a vertical shrink? It's a vertical stretch because we multiplied by a number greater than 1. All right, so then we got to 4 lessons involving exponential functions. All right, so you find the y-intercept. That's your first number. We started with x. Then the base is the constant ratio. We're multiplying by 3 here. So that's our constant ratio. And it's 3 to the x. So it's f of x. Let me write it clear. 4 times 3 to the x. Like that. Right? And to evaluate that, you would do exponents before multiplying. Next one. So we're dividing by 2 here, or multiplying by 1/2. Right? So this is f of x. And our y-intercept is 128. Now, because we have a fraction base, we need to have the parentheses. Oh, that's right. Well, the first day I wrote this like that, didn't I? Yes. And so 1/2 x, 1/2 to the x. Now, these parentheses, right? There's no points off. Do not worry about the parentheses on the first one here. Where you put them really doesn't matter. You just have to indicate, you're trying to indicate that you do your exponents first before you multiply by 4 to people who forget that. Over here, though, these parentheses around the 1/2 are absolutely required. Because if you write this, that means 1 to the x divided by 2, not the same thing. So you cannot, this one has to be exactly that way. So this one has a t, so we're going to use t. And we have y-intercept of 0.50. Now, right, so this is where we're going to use percents, right? So, right, 6/5, right, is 1 1/5, also known as 1 2/10, right? Also known as 1.2. It's 20%. We're going up by 20%. The number is going up by 20%, and I've been writing this both ways, have I not? It doesn't really matter. So 1.5 t. So that's right, 20. It's getting 20% higher. If you do 72 over 60, you also get, well, let's just divide those both by 12. You get 6/5, which is 1 1/5, which is 1 2/10. This one is decreasing. All right, so it's f of t equals 500 is our, right, where x, or in this case t equals 0 is our y-intercept. And we're going down, so it's 450 divided by 500. So it's 45/50ths divided by 5, and you get 9/10 or 0.9. So this is 0.9 to the t. All right, so we're going to fill in the t-table and write an exponential function for this graph. So let's look. At -3, we're at 48. -2, we're at 24. -1, looks like we're at 12. At 0, right, let's look at each box here. So that's 6. We're at 6, right? So each box here is worth 3. So yeah, each box is worth 3. So that is at 6. So 1, we're at 3. Now let's see what we're doing here. We're multiplying by 1/2, aren't we? Also known as dividing by 2. So the next one should be at 3/2, right? right? That's not obvious there that that's at 3/2, 1.5. And let me clean this up a little bit. That looks a little too messy. That's at 3/2 or 1.5. And then we have to multiply that times 1/2, and you get to 3/4, right? 3/2 times another half is 3/4. So we realize that our constant ratio here is 1/2. Our y-intercept is right there, 0, 6. So this is f, we're using x, so it's not t. F of x equals 6, and you could write it as 0.5 or 1/2, 1/2 to the x. Now don't write a t there when you put an x there. F of x equals 6 times 1/2 to the x. All right, so you're paid $1 on the first day and double the amount each day after that. Okay, so f of x, dollar, our starting amount is $1. We can leave that out. And we're doubling it. That means we're multiplying it by 2 every single time period. So to do f of 7, you do 2 to the 7th, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is $128. So you'd be paid $128 on day 7. Video game tournaments started with 256 players. If half of them are eliminated, all right, so if half of them are eliminated, that means half of them are still there, right? 1 minus 1/2 is 1/2. So we start with f of x, start with 256, and then it's 1/2 to the x. Well, I put f and t. Oh, bad. So if I put x there, I should put x there. So we're going to do 1/2 to the 4th. So 1/2 times 1/2 is 1/4, 1/8, and that's 1/16. So it's 256 times 1/16. So we better see how many times 16 goes into 256. And I'm getting 16 and 96. Let's see. Is that 16 times? Yeah, it is. So we have 16 players left after 4 rounds. So the number of students in a school is predicted to grow. Make sure you read it, not decrease, grow, because we've done sort of both. Right? So we're starting with 400 students again, and we're growing by 10%. So if you start at 100% and grow 10%, you get to 110%. But 110%, what is 110%? It's 110 out of 100, also known as 11 tenths, also known as 1 1/10, also known as 1.1. Now, most people do not go through all that. They just move the decimal twice. 110% is 1.1. So it's 1.1. We're writing a linear function, f of t, and t here would be 5 years. Okay, so we have to do 1.1 to the 5th. Yes, you are allowed to use a calculator on this test. There will never be another, well, this is, we at the end of the year here, but yes, this is the one you're allowed to use a calculator. But if you don't have one, you could do 1.1 times 1.1, so on. I didn't make it horrendous. So 1.1 to the 5th power is 4, so it is 400 times 1.61051. We have to multiply that times 400. And it equals 644 students. Yeah, it's approximate. There's some extra there. It's a word problem. So we grew 10% over 5 years, and now we're at 644 students. All right, so if you pay annual compound interest of 3%, so we start with 4,000, then it's 3%, 100% plus 3% is 103%, also known as 1.03. Don't do 1.3. You wish you got a 30. That's 30%. So it's 1.03, and we're doing to the 10th. Now you're going to notice on the test, I have smaller numbers there generally because some people may not have a good calculator, and so I help them out. 1.03 to the 10th is approximately 1.3439 and a bunch of other numbers. And so we have to multiply that times our 4,000. And so 10 years later, in your account will be $5,375.66, let's say approximately 5,376. And I would make these multiple choice on the test so that we won't have any rounding issues generally. I might put one where I ask you to round, doubtful. Right. An $80,000 car loses about 20% of its value per year. So it starts at 80,000, goes down 20%. So it's 80% lower each year. So we're using 0.8. So it's 0.8 to the fifth, right? And so I need to do 0.8 times 0.8 and so on. 0.8 to the fifth power is 0.32768. We're multiplying that times 80,000. And so, let's say 5 years later, your $80,000 car is only worth $26,214.40, 0.4. Right? And it turns out that houses are a big exception. Houses, when you buy a house, because of the land underneath it mostly, it increases in value. But most everything else you buy decreases in value because it gets old and people don't want old stuff, they want new stuff. And it usually goes down following an exponential function, right? So it loses a lot of value at first, but it doesn't go down to zero or go negative, right? Something can't be worth negative amount of dollars. So it gets closer and closer to zero, but usually not reaching actual zero, right? Even if you put something out of the curve, other people find value in it. All right, so this is a big one. You're going to hear in the press that a species is losing 50% of the animals every year. And there will be a bunch of people who listen to that or see a headline and think, well, in 2 years, right, 100% of them will be gone. No, it doesn't work that way. Okay, so this has got no, right, the y-intercept is 1 here, right? So if you lose 50%, right, then you have 50% from 100%. You still have 50% left, or 0.5. So this is 0.5 to the t. I guess I should write it out, right? And so it's going to be 0.5 to the fourth. So if you lose 50% of the population per year, it's 0.5 times 0.5 times 0.5 times 0.5, or 0.0625. Well, let's write that. It's still really bleak, right? It's 6.2. You lose 50% per year, right? So it'd be 50%. Then the next year, right, it'd be down to half of 50%, 25%. Then half of that, 12.5%. Then half of that, 6.25%. After 4 years. That's what really goes on, all right? It slows down as we get closer to nothing. Still bad. Final question. So you better be able to tell the difference between a linear or an exponential function. That actually is the standard for this, for 8th grade, for Algebra 1, I should say. So this one, we're adding 20 each time. This one, we are doing 60 over 40, or 6/4, which is 3/2, which is 1/2, which is 1.5, which is 150%. And if you want to check some of the other ones, yes, that also makes 3/2 and so on. So this one is exponential, right? It's going up at a constant ratio. This one is linear. So let's write a function for both of these. The exponential, we've been doing a million of those. Right there, it's f of t equals 40 is our y-intercept, and it's 1.5 to the t. It's going up 50%, or 1.5. And 50% more. Here is linear, so our y-intercept is 40, and our slope is 20. It's going up by 20 every single time period. Good luck on the test. Do not take it until you're ready.